ignore this. So I put the height in because in the book, you don't see this problem, but you guys should be able to do it. So that yellow dotted line is your height, so it's a right angle. So because this is isosceles, it's symmetrical, so both of these are 4 centimeters. That gives us this formula. So this is 16 plus h squared equals 64. That's right, so subtract the 16. And then square root your leftover here, which is 48. Okay, some of you need a little refresher on how to do that. If I ask you for the exact answer, that means you need to leave a simplified square root in your answer. If I ask you to round, then you use the approximation that we talked about, but you should be able to do both of them without a calculator. So from, last year you learned different techniques, but probably something like this, where you either found pairs and said this was equal to 4 square roots of 3, or you rewrote this as a perfect square, like 16 times another perfect square, 3, and that's 4 square roots of 3. One way or the other, you came up with 4 square roots of 3. Okay?
Wait, what? Oh, okay, I see.
All you did was you just did come the square root above it and below.
No. So there's two different things.
We did this
The exact answer does not use an approximation. The exact answer would be half the base times the height, which in this case, half the base is 4, and the height is 4 root 3. So the exact answer is 16 square roots of 3 centimeters squared. That's the exact answer. So hold on, let me just make a little more space here. So we're not to number 9 yet. Okay, so a decimal approximation, what you did last year was you put 48 square root between 36 and 49. And this is 6 something, and the difference between 36 and 48 is how much? 12, and between 36 and 49, 13, so very close. So it's an approximation, so you might have said it was about 6.9, approximately.
And could you just...
And then use that in your calculation of the problem. So it depends on what's being asked. If I'm asking you for the exact area, that's the answer. If I say give an approximate area to the tens place, then your area is half the base times the height, which is still 4 times 6.9. Now we're doing an approximate now. And so 4 times 6 is 24, right?
Yeah.
And 4 times 9/10 is, what's 4 times 9? So 4 times 9/10 is 3.6.
I don't get how you got the 16 square root.
Well, no, this,
Yeah.
that's from last year's simplifying square roots. So we can talk about that, but we should talk about that a little bit later. Like, come in tomorrow morning, we'll practice it here.
Okay.
Because you have till Wednesday, and it's just something you need to review. And so then your answer is going to be still centimeters squared. Okay. So that's an approximate. There's a difference. Okay? So something you should be able to do by yourself that's not in the book is find the area of an equilateral triangle if they don't give you the height or the apothem. Because they do, and you guys don't need it. Okay, the next thing, similar situation would be like problem 9 in the homework. You had or in the quiz, you had a hexagon. So if I said, say this is 20 inches, and this is 10 inches, and you have a regular hexagonal prism, you should be able to find the surface area. In order to do that, you have to know how to find the area of that hexagon. Does that make sense?
Yeah.
And then you have to add 6 rectangles. Okay, so in other words, you would have two hexagons, you know, the top and the bottom, and then you need the area of each of those, and then you would add that to the lateral surface area, which is the 6 rectangles.
How you, oh, it gives.
So the 6 rectangles are the easy part, 10 by 20. So each one rectangle is 200 square units. And the hexagon's the more complicated part. But since it's a hexagon and it's regular, there's 6 equilateral triangles in there, which is why I just did that equilateral triangle problem. So, in other words, you have 6 equilateral triangles, and in this case, they're 10 by 10 by 10. So you would put in that height again. So in this case, you would have h squared, or in our problem, we call it the approximation. A squared plus 5 squared is equal to 10 squared.
So the 10 isn't the common.
The 10 is not.
That's coming out of that.
That's correct.
That's okay.
Right. And that is an 8 out of 9. That's where you made the mistake. So this is a squared plus 25 equals 100. So subtract 25. And you have a squared equals 75. So if I want the exact area, the square root of 75 is the same as the square root of 25 times the square root of 3. So that's 5 square roots of 3.
I remember.
Is it coming back?
Yes. But what if you can't find one that's...
You have to find pairs. If there are no pairs, you leave it in square root. An example
So
being
you
like,
just leave it to square root of
right.
75.
An example would be is if I said, what's the square root of 21? You'd say it's the square root of 21. Because there's no pairs in 21. You only have 3 and 7.
So in that case, if you...
So you would just say it's the square root of 21. Okay? So your apothem is 5 root 3. So I'm going to bring in another page so we can look at the picture and do the work without squeezing it all in here. So you know now that you have 2 hexagons, and the area of the hexagon is 1/2 the apothem, which is 5 square roots of 3 times the perimeter. And again, if you don't have a calculator, you kind of just want to keep everything separate and simplify as much as possible. So this is the hexagons, 2 hexagons. Plus 6 rectangles, which we already know is 200 times 6. So then you could simplify, like 2's cancel. Okay? 5 times 6 is 30, times another 10 is 300. So this is just 300 square roots of 3 plus 1,200. And you can't combine those. So this would be in squared inches. If you had just to do the hexagon, it would be 300 square roots of 3. And I think you guys had access to a calculator. So when you multiplied that out, oh, actually, the hexagon right here is this in here. So on your actual quiz, that was the hexagon. So I think it was 150 square roots of 3. But I doubled it because of the picture. So does that answer your other question? So that's the surface area of a regular hexagonal prism. You should be able to do any prism. That's your homework tonight, because now you can calculate all these different polygon areas. How are we doing so far? Keep going. So surface area of a cylinder. We're probably going to run out of time for surface area of a cone, and I will talk to you about it tomorrow. But surface area of a cylinder you did in 8th grade math, which would have been 2 years ago. So it's 2 circles plus a rectangle, right? And the distance across this rectangle is the circumference, right? So that's pi d. And then the height would be whatever the height is here, and the radius. So this is your radius here. This would be the height of the prism. So in general, your formula would be 2 times the area of a circle, which is 2 times pi r squared. That's the circle part. Plus the area of that rectangle, which is pi times the diameter times the height. Does that make sense? Now where it gets a little more complicated is if you have a cylinder with like a hole bored through it. You know, if you drill through the center of it, you're actually adding on the surface area of the inside. Miranda? Yeah, the 8.4 maybe? 8.6, yes it is.
Except it's a 3-dimensional.
But it is that this piece is exactly 8.6, and that's why I was saying study for your test. If you study for your test through the 8.7 tonight, that's at the beginning of studying, you have 2 of those, so you have 2, and if I put some values in here, like say the big radius to be, you know, 5, and then they'll usually draw a little picture like that, and the smaller radius, they'll use a lowercase r to be 3, for example. Then you have 2 of these annuluses plus a rectangle that is the outside, and then a rectangle with the same height but not as big a circumference, that's the inside. So this rectangle, if your height, let's say, was 10, would have the dimensions of 10 by 10 pi, because of my capital R being 5, pi d. This is the diameter of the outside is 10. So the circumference is 10 pi. Does that make sense? The little diameter in here would be 6. So this is 6 pi. But they both share the common height of 10. So far, are we okay? You just have to break it down. And so then this is 2 times the big circle minus the small circle, plus those 2 rectangles. Because you have a ring, you have this annulus, you don't have the small circle.
But then why do you think this surface area of the inside?
Because if you bore a hole through something, imagine dropping it in a bucket of paint, would the inside be covered?
Yeah.
Yeah, so that's new surface. You've created new surface. You've also taken down a little bit in the top and the bottom, but you're creating an inside.
Okay,
So
I wasn't thinking that as like a hole drilled through, I was thinking of a different cylinder inside.
yeah, so you have to. So this is 2, and then it's 25 pi minus 9 pi, plus this would have been 100 pi here, plus 60 pi. Does that make sense? So this is 2, so 160 pi. So this is 2 times, what's 25 minus 9? 16 pi, right? Plus 160 pi, so 32 pi plus 160 pi, so 192 pi, and then squared units. And if you were asked for the exact answer, you would leave pi in it. So we did everything but cone. I'm going to give you the formula for cone, but we have to talk about how you get bonus points.
separate cones.
So just real quick, surface area of a cone, you have the height, which you use for volume. You have the slant height, which they usually call L, and you have the radius. Use the formula tonight, pi r squared plus pi rl. And the pi r squared is the circle, the pi rl is the sector. I talked to the other class about how they could get bonus points if they can explain where the formula comes from. But for right now, in the time that we have, we'll just use the formula and talk about it tomorrow. The video.